In question 1, we are asked to work out 2 and a 7th plus 1 and a quarter. So we need to show full working here. We start with 2 and a 7th, which we will write as 2 and 4 over 28. In other words, we found the lowest common multiple of 7 and 4, and this is 28. And 1 and a quarter is 1 and 7 over 28. And now I'll be doing the integers with the integers, so 2 plus 1 is 3, and then the fractions with the fractions, 4 plus 7 it's 11, so that's 3 and 11 over 28. In B, we're asked to work out 1 and a 5th divided by 3/4, so we're looking at division with fractions. So two things I will do at the beginning is write 1 and a 5th as an improper fraction, and I will also turn division into multiplication by flipping the second fraction. So we say that 1 and a 5th is 6 over 5 times 4 over 3. Now we do have some simplifications. The 6 with the 3 leaves me a 2 and a 1. So this gives me 2 times 4, which is 8 over 5. The question was asking for an answer in mixed number form. So 8 over 5 is 1 and 3/5. In 2, we are told that the ratio of houses to flats is 7 to 4. The ratio of flats to bungalows is 8 to 5. We've got 50 bungalows in the village, and we need to work out how many houses are there in the village. So I will start by writing out 3 headings. We've got houses, flats, and bungalows. We've got the ratio of houses to flats to be 7 to 4, and then flats to bungalows to be 8 to 5. We need to find a way for all 3 of these to communicate, and it actually makes sense to multiply this by 2 so that flats will be 8 here and houses will be 14. So let me write that down. We've got 14 to 8, and therefore we conclude that the ratio of houses to flats to bungalows will be 14 to 8 to 5. Now we have been given that there are 50 bungalows in the village, so I'll write a 50 here. It's obvious that we've got a times 10 here, so I will times 14 by 10. I get 140, and therefore we conclude that there must be 140 houses in this village. In 3, Rene buys 5 kilograms of sweets to sell. She pays 10 pounds for these sweets. She puts them in bags of 250 grams each, selling them for 65 pence. We need to work out her percentage profit. I will start by converting the 5 kilograms into grams by multiplying by 1,000. So we've got 5,000 grams of sweets to start off with. Well, each bag contains 250 grams. So 5,000 over 250 to give me the number of bags. Well, the 0 with the 0 will cancel out. 25 into 50 goes 2 times. So we've got a total of 20 bags that were sold. Now, each of them was sold for 65 pence. So 20 times 65. Well, 2 times 65 is 130. And another 0, we've got 1,300 pence, and this is 13 pounds. In order to calculate the profit now, the percentage profit, I will do the amount of money we received, so the income, which was 13, divided by 10, which was the amount of money we paid to buy these sweets. We get an answer of 1.3, which I can think of as 1.30. So the multiplying factor to take me from the original amount of money I paid to the amount of money I received is 1.30, which corresponds to a 30% increase, and therefore the profit is 30%. In 4, we had a cycle race. The length was 3,069.25 miles in length, an average speed of 15.12 miles per hour. For the next race, they will be cycling for 8 hours per day, and we need to estimate. The keyword here is estimate how many days they will take to complete the race. So remember, I don't have a calculator, so I will be approximating the values given here. So I will start by saying 15.12 miles. I will say this is approximately 15 miles. So if we were racing at a speed of 15 miles per hour, this means we were covering 15 miles every hour. And I would like to know how many miles I will be covering in 8 hours, which is the amount of time I will be cycling per day. So to find x, I will do 15 times 8, which is 120 miles. So this means we will be covering 120 miles per day. Now we need to cover a total distance of 3,069.25 miles, and I think it makes sense to say this is approximately 3,000 miles to be covered. I will be covering 120 miles per day. So if I do 3,000 divided by 120, this will give me the number of days I expect to take to complete the race. So the 0 with the 0 will cancel out. Now the 30 with the 12, both are divisible by 6. So this is 5 and this is 2. So this gives an answer of 50 over 2, which is 25 days. We are then told that you run trains for the race. The average speed increases. It is now 16.27 miles per hour. And how will this affect our answer to part A? Well, obviously, if the speed increases, it means we're covering more distance on a daily basis. And therefore, we can simply say that we will be completing this race in less than the 25 days we calculated before. In question 5, we're given a solid square-based pyramid VABCD. We are asked to draw an accurate front elevation of the pyramid from the direction of the arrow. So if we look at the pyramid this way, we will be seeing essentially the cross-section which we have highlighted here. This is simply an isosceles triangle with a base of 6 centimeters in length and the slant height here 5 centimeters. So going on my grid here, I will be drawing something like this. We've got 2, 4, 6 centimeters in the base. We've got 5 this way and 4 is the height here. We are then told to work out the total surface area of the pyramid. Remember, it's a square-based pyramid. So I will start by considering the base here, which I'm highlighting. It is a square measuring 6 by 6, and therefore to start off for the total surface area, I certainly need a 6 times 6 for the base, and then I will be needing to consider the triangle here, and we've got 4 identical triangles. Each of these triangles, it's an isosceles triangle with a base of 6 centimeters and a height of 5 centimeters, and therefore to find the total surface area because of these 4 triangles, I will be having 4 times base times height over 2, so 6 times 5 over 2. Now the 6 with the 5 simplified to leave me with a 3, and therefore we've got 36 plus 4 times 15. This is 36 plus 60, which turns out to be 96 square centimeters. In question 6, we've got a pattern made from 4 identical squares as shown here. We've got the coordinates of point A and point B, and we need to work out the coordinates of point C. So let me start by considering the x coordinates of A and B. So from 6 we go to 38. Each of these is a square, so I can call its base length to be x. So we've got x plus x plus x plus x. So in other words, I can simply say that to go from the x coordinate of A to the x coordinate of B, I will have to add 4 x's. So we have that 6 plus 4x is equal to 38. So 4x is 32, which means that x is 8. So we have found x, the length of the side of the square. So I can simply say that to find the x coordinate of C, I will simply do 6 plus 2 x's. So 6 plus 2 times 8 will be 6 plus 16, which is 22. So the x-coordinate of point C will be 22. And I now need to consider how to find the y-coordinate of C. Well, obviously, from B, I need to go down one full length and another full length, so 2 full lengths, as shown here. So from 36, I need to deduct 2 times 8. So this is 36 minus 16, which is 20, and therefore C has coordinates 22, 20. In question 7, we start off with triangle T. It's reflected in the line x is -1 to give shape R, and then shape R is reflected in the line y is -2 to give shape S. And we need to describe the single transformation that will map T onto S. So it makes sense to start by drawing these two reflections. So this is the first mirror line, x is -1. We reflect along this line, we get the R, which was the image of T. And then we will be reflecting along the line y is -2 to give us S. And we need to work out the single transformation that will take T to S. So we immediately spot that a rotation makes sense. I can use my tracing paper. Remember, we are allowed to use a tracing paper in the exam. And we notice that the center of the rotation is exactly where the two mirror lines meet. And we go through 180 degrees. It doesn't matter whether we're clockwise or anti-clockwise. So we're looking at a rotation with center being the point -1, -2 through 180 degrees. An alternative transformation you could consider would be an enlargement, and you can join corresponding vertices between object and image to determine the center of this enlargement. So if we do that, we notice that all rays pass through the point with coordinates -1, -2. And when the center of the enlargement is in between the object and the image, then the scale factor is negative. And since the size has not changed, we're looking at an enlargement with a scale factor of -1 and center the point -1, -2. In A, the perimeter of a right-angled triangle is given to be 72 centimeters. The lengths of the sides are in the ratio of 3 to 4 to 5, and we need to work out the area of this triangle. Well, I will start by drawing a right-angled triangle. We know that the ratio is 3 to 4 to 5. Obviously, the 5 corresponds to the hypotenuse, being the longest side. So I could call this 5x, this 4x, and this 3x. And we know that if we add up the three sides, we get the perimeter. So 3x plus 4x plus 5x is 72, leading to 12x being 72, which makes x 6. So now that we know that x is 6, we can easily go back to the triangle and say the base is 24 centimeters, the height is 18 centimeters, and the hypotenuse will be 30 centimeters. And therefore, to find the area, I will simply do base, which is 24, times height, which is 18, over 2. Now the 24 with the 2 will cancel out to leave me with the 12 in the numerator. So 12 times 18, I can do this as 10 times 18 plus 2 times 18. This gives an answer of 180 plus 36, which is 216 square centimeters. In 9a, we need to write down the value of 36 to the power of a half. Well, we know that 36 to the power of a half is simply the square root of 36, which is just 6. In b, we need to write down the value of 23 to the power of 0. Well, anything to the power of 0 is always 1, so 23 to the 0 is 1. In c, we need to work out the value of 27 to the minus 2 over 3, so we've got a negative fractional index. So I will start by writing 27 to the minus 2 over 3 as 1 over 27 to the power of 2 over 3. In other words, I consume the negative sign in the index by flipping the base. So 27 is written as 1 over 27. And then this is the third root of 1 over 27 raised to the power of 2. So in other words, the denominator became the root and the 2 is here. Now the third root of 1 over 27 is a third. This is because a third times a third times a third is 1 over 27. So we've got a third to the power of 2, which is 1 over 9. In question 10, we're given information about the heights of 80 girls. We have the least and the greatest height. We've got the lower, the upper quartile, and the median, and we need to draw a box plot. I will start by using the lower quartile, the median, and the upper quartile to draw the box. So there it is. And then I extend to the left up to 133, which was the least height, and to the right up to 170, which was the greatest height. So this is the box plot. In part B, we need to work out an estimate for the number of these girls with a height between 133 and 157. So 133 was the least height and 157 was the upper quartile. So if we look at the box plot, we can see that we've got the least height here, and then it's Q1, Q2, Q3, and then the maximum over here. This means we are splitting the data into parts of 25%, and we would like to be between 133, which is over here, and 157, which is over here. So we need to take this part here. We need to take 75%, so 75 over 100 of the total number of girls, which was 80. So 75 over 100 times 80. 75 over 100 simplifies to 3 over 4, and then the 4 goes 20 times into 80, so 3 times 20, 60 girls. That's the number of girls with a height of between 133 centimeters and 157 centimeters. In 11, we're given A and B points on a circle centered at O. We are told that the line BC is a tangent to the circle. Angle ABO, it's over here, it's X. And we need to find the size of the angle ACB in terms of X. We need to give reasons for each stage of our working. So it makes sense to start by drawing the line joining OB. This is the radius here. And we notice that this is the angle X that we have been told. And also the triangle OAB is an isosceles triangle because the two sides are both radii, so they are equal in length. So we immediately know that these two angles are X. So I will start by saying that angle OAB is equal to X. Remember, I have to give reasons here. So angles at the base of an isosceles triangle are equal. We also notice that the line BC is a tangent to the circle, which means that the angle OBC should be 90 degrees. So I have to state this. OBC is 90 degrees. The reason is that we've got an angle between a tangent and a radius at the point of contact being 90 degrees. And now we can consider the triangle ABC. We have that the angle here ACB should be such that the sum of the angles in a triangle give a result of 180. So I can now say that ACB will be 180 minus the X, and the 90. So X plus 90. Now the 180 that appear here is justified through angles in a triangle adding up to 180 degrees. So I can now proceed to simplify this expression. It's 180 minus X minus 90, which simplifies to 90 minus 2X. In question 12, we are asked to prove that the square of an odd number is always one more than a multiple of 4. So we are being asked to construct a solid mathematical proof here. We need to keep it abstract in the sense that we cannot fix on a particular odd number. It has to be a proof that works for all odd numbers. So I will start by saying, let us consider 2n plus 1 all squared. where n belongs to the natural numbers. Now, natural numbers, the set of natural numbers is the set of positive integers. 2n plus 1 is an odd number because 2n is always even. If I add 1, it's going to be odd. So I'm now considering the square of an odd number. So 2n plus 1 squared is equal to 4n squared plus 4n plus 1. I notice that the first two terms, the 4n squared plus 4n, have a common factor of 4. So this is 4 brackets n squared plus n close brackets plus 1. So I have just written this as a multiple of 4 plus 1, which is exactly what I had to do. Now, the only thing missing is a conclusion to complete the proof, and therefore I would say, i.e., the square of an odd number is always 1 more than a multiple of 4 as required. In 13, we're given root 5 brackets root 8 plus root 18, and we need to show that this can be written in the form of a root 10, where a is an integer. So let's start by considering what we were given. Before expanding, I will focus on what's in the brackets. I will write root 8 as root 4 times root 2 and root 18 as root 9 times root 2, because it will give me an expression in terms of root 2. So we're looking at root 5 brackets 2 root 2 plus 3 root 2. So this is root 5 times 5 root 2. Now we'll do the roots with the roots and the integers with the integers. So root 5 times root 2 is root 10, and the 5 stays. So this is 5 root 10, which means that the value of a is simply 5. In 14, we are told that y is inversely proportional to d squared. We know the value of d when y is 4, and then d is directly proportional to x squared. And again, we've got a pair of values for x and d. We need to establish a formula for y in terms of x, giving our answer in its simplest form. So starting with the first piece of information, y is inversely proportional to d squared. So y proportional to 1 over d squared, which means that y is k over d squared, where k is a constant of proportionality. We know that when d is 10, y is 4, and I will use this information to find the value of k. So 4 is k over 10 squared. 4 is k over 100, which means that k is equal to 400. And therefore, the relationship between y and d is y is 400 over d squared. At the same time, we are told that d is directly proportional to x squared. So we have that d proportional to x squared. So d is mx squared. Notice that I'm using a different constant of proportionality to avoid confusion with the first constant of proportionality I have introduced. We have been told that when x is 2, d is equal to 24, and therefore 24 is m times 2 squared. So 24 is 4m, and therefore m is 6, which means that we have that d is 6x squared. Remember that we are trying to find a formula for y in terms of x. So looking at the formula for y, we see that it involves a d squared term. So I will actually go to the formula for d in terms of x and square everything. So d squared is 36x to the power of 4. And now I can join these two equations together. We have that y is 400 over d squared, which is 36x to the power of 4. Remember, we're looking for a simplified answer. Now 36 and 100 have a common factor of 4. So this is 100 and this is 9. And this leads to y is 100 over 9x to the power of 4. In 15a, whereas to factorize a squared minus b squared, we should recognize this as the difference of two squares, which factorizes into a minus b brackets a plus b. In b, it says hence or otherwise. Simplify fully this expression here. Well, if I want to go with the hence, I notice that we are again looking at the difference of two squares, maybe in a somewhat more complicated context. So this is the expression I'm given. I will start by considering x squared plus 4 being my a and the x squared minus 2 being my b. So this will give me x squared plus 4 minus brackets x squared minus 2, and that's the first set of brackets. And then we have x squared plus 4 plus x squared minus 2. So I'm mimicking exactly the idea here. I will simplify this. In the first set of brackets, I've got x squared plus 4 minus x squared plus 2. And in the second set of brackets, I've got x squared plus 4 plus x squared minus 2. This simplifies to give me 6 brackets 2x squared plus 2. I can factor out the 2, and this is 12 brackets x squared plus 1. Now alternatively, I could have expanded this expression here, so I completely ignore the hence. I go with the or otherwise. So what I will be looking at is x squared plus 4 all squared minus brackets x squared minus 2 all squared. So this means I've got x squared plus 4 times x squared plus 4 minus x squared minus 2 brackets x squared minus 2. And I will carefully expand everything. I get x to the power of 4 plus 4x squared plus 4x squared plus 16 minus brackets x to the power of 4 minus 2x squared minus 2x squared plus 4. So we've got x to the power of 4 plus 8x squared plus 16 minus x to the power of 4 plus 2x squared plus 2x squared minus 4. We notice that the x to the power of 4 term will cancel out. I've got 8x squared plus 2x squared plus 2x squared, which is 12x squared plus 12. If I want to proceed into factorizing, it's going to be again 12 brackets x squared plus 1. Remember, the instructions were to simplify fully. I can stop here, or I could give my answer like this. Both of them are acceptable. In 16, we've got a bag containing only red, blue, and purple counters. Now the ratio of red to blue is 3 to 17, and the probability of picking a purple counter is 0.2. We need to work out the probability of picking a red counter. So this is the three different colors I'm dealing with. I have been told that the ratio of red to blue is 3 to 17. The probability of a purple one is 0.2. This means that the probability of picking a red or a blue one is 0.8, and I need to split this in the ratio of 3 to 17. So obviously I will do 3 plus 17 is 20. We're trying to find the probability of picking a red counter, so 3 over 20 times 0.8. So I can write this as 3 over 20 times 8 over 10. I will simplify the 20 with the 8. Both are divisible by 4, leaving me a 5 and a 2. And then the 2 with the 10, leaving me 1 and a 5. So we've got an answer of 3 over 25, the probability of picking a red counter. In 17, we're asked to simplify fully the expression given here. So we're looking at an algebraic fraction. We will start by factorizing the numerator. This will give us 3x plus 1 brackets x minus 3. And also in the denominator, we see there's a common factor of 2x. So it's 2x brackets x minus 3. And then we notice that the x minus 3 can go away. And this leaves us with 3x plus 1 over 2x. In 18, we've got the graph of y is sine x between minus 180 and 180, and we need to sketch sine x minus 2. Well, this is a translation 2 units down, so we deduct 2 from y. So the origin will now be mapped to the point 0 minus 2. The cut at minus 180, 0 will now be at minus 180, minus 2, and so on. So we expect to see the full graph being moved 2 units down, and this is y is sine of x minus 2. In 19, we've got the point P with coordinates 3, 4, and the point Q with coordinates A, B. A line perpendicular to PQ is given by this equation here, and we need to find an expression for B in terms of A. So I will start with the equation of the straight line I was given. 3x plus 2y is equal to 7. I would like to find the gradient of this line, and I will do this by making y the subject. So 2y is minus 3x plus 7. I will be dividing throughout by 2, leading to y is minus 3 over 2x plus 7 over 2. We know that any equation of the form y is mx plus c has a gradient of m. So in our case, the gradient is minus 3 over 2. And I will now be using the fact that the line is perpendicular to PQ. This means that the gradient of PQ is 2 over 3. I'm using the fact that if two lines are perpendicular to each other, then the product of their gradient is negative 1. So to find the gradient of the perpendicular to minus 3 over 2, I flip and I change the sign. And then now that I know that the gradient of PQ is 2 over 3, I'll be using the fact that we've got the coordinates of P and the coordinates of Q. Recall that the gradient is given by y2 minus y1 over x2 minus x1. So in our case, it's going to be b minus 4 over a minus 3. And we have just established a relationship between b and a. We need to isolate and solve for b. So I will cross multiply. 2 brackets a minus 3 is 3 brackets b minus 4. Expanding to give us 2a minus 6 is 3b minus 12. This leads to 2a plus 6 is equal to 3b. And I can now divide throughout by 3 to get 2a plus 6, and all of it over 3 is equal to b. We were looking for an expression for b in terms of a, so we need to have b equals something in terms of a, and this is the final answer. In 20, we have that n is an integer satisfying that 3n plus 2 is less than or equal to 14, and at the same time 6n over n squared plus 5 is greater than 1, and we are asked to find all possible values of n. So we're dealing with two inequalities. Let me start with the linear inequality of 3n plus 2 being less than or equal to 14. So 3n is less than or equal to 12, which leads to n being less than or equal to 4. Now let's turn our attention to the second inequality. 6n over n squared plus 5 is greater than 1. I can cross multiply to give me 6n is greater than n squared plus 5 without the need to worrying about whether I'm multiplying by something negative, because n squared plus 5 can never be negative. Remember that with inequalities, we solve them exactly the way we would solve equations, with the only exception being that if we multiply or divide by a negative number, we need to reverse the inequality direction. Well, in this case, n squared plus 5 being positive means I don't have to reverse the inequality direction here. So we are essentially dealing with a quadratic inequality. I will collect everything on the right-hand side. So 0 is greater than n squared minus 6n plus 5. I will be factorizing this into n minus 1, n minus 5, and therefore we can look for critical values. The critical values are at n minus 1 is 0 or n minus 5 is 0. So we've got that n is 1 or n is 5. And I can proceed in drawing a parabola, a smiley face parabola, in order to identify the region where n could be. So it's a smiley parabola. We've got cuts at 1 and 5. It goes plus, minus, plus. The inequality says that this should be less than 0, and therefore we are interested in the part over here. So we've got that 1 is less than n, less than 5. Now that we have solved the two inequalities independently, it makes sense to put them together on a number line. So I've got a number line here for n. We have found from the first inequality that n is less than or equal to 4. So I've got a full circle at 4 going to the left. And from the second inequality, the quadratic inequality, we obtain that n is between 1 and 5, and this is a strict inequality. So we've got empty circles at 1 and 5, and we want both of these to be satisfied, and we can see from the number line that this is the region where both of them are satisfied. I will be shading this in red as shown here. So we see that 1 is less than n is less than or equal to 4. Remember, we were asked to determine all possible values of n, taking into account the fact that n is an integer, and we can see that the only integers in this set are simply 2, 3, or 4. It was a strict inequality for 1, so 1 is not a suitable candidate. However, we had a relaxed inequality for 4, so n could attain the value of 4.